So back to series and sequences. Start off with just some applications. I thought the easiest way of doing that is looking at some HSC ones and things like that. So it's an old one now, 2007. Heather has decided to improve her fitness level very ambitiously. So we're talking about someone who's starting at a base level, says, I want to improve my fitness level. I know, I'll go and swim 750 metres. Not bad for the first day of this new approach. And then, just to top it off, every day after that, she's going to swim 100 metres more than the previous day. That means the next day she swims 850, then 950, and so on and so on. Write down a formula for the distance she swims on the nth day. The first term, 750. The common difference, 100. General term, a plus n minus 1d. Sub in, rearrange, and there we go. We have a formula. 650 plus 100n. So how far does she swim on the 10th day? Well, that would be T10. Substituting 10, she's now up to 1,650 metres. Yeah, it's not bad. So what is the total distance she swims in those first 10 days? Well, that now would become sum to n formula. Sub in n is 10, d is 100, 12,000 metres. Of course, another way you could have done that is you could have used the a plus l formula, because you've just worked out how many she did on the last day. So you could go a plus l, and again you come up with 12,000. After how many days does the total distance she swam equal the width of the English Channel? That's 34 kilometres. All right, so we want the sum to be 34,000. It's n we're trying to find. So we end up with a quadratic. Multiplies together to give negative 680, adds to give 14. 34 and negative. Pretty clever.
That's pretty obvious.
Think about it. If she was clever, it says n equals negative 34 or n equals 20. So really it's 20 days. But if you think about it, she should have she should have on the first day just gone, I did that 34 days ago. But let's have a look at this one. Company sales declining by 6% every year. 50,000 items sold in 2001. When will sales first fall below 20,000? So A is 50,000. Our ratio is 0.94 because it's decreasing by 6, so the actual ratio is 94% each time. We want to know when is our general term less than 20,000. So AR at the n minus 1. Okay. We need to make n the subject of this little inequality. So eventually 0.4. Here we go. It's in the power. So we log both sides. Now, what do we have to watch out for here? Because I'm about to divide by log of 0.94. Yes, because it's a negative number. And if you change the sign...
You change the sign.
Very good. See, we've learnt some things. So n minus 1 is greater than 14.8, etc., etc. So we're looking for the first time n is bigger than 15.8. 16th year, 2016. All right, back to another HSC question. Anne and Kay are employed by an accounting firm, but they took on different conditions of employment. Anne said, look, I'll accept $50,000 and then every year just increase my salary by $2,500. Kay said, well, yeah, look, I'll also start at $50,000, but I want a 4% increase every year. Who's the smarter person? Anne is arithmetic. A is 50,000, D is 2,500. K is geometric. Ratio 1.04 because we're increasing by 4%. So the first thing they want to know is, what's Anne's salary in the 13th year? So general term. Sub in. $80,000. Okay. What about K then? Who was the smarter one? ARN minus 1. Oh, got it by $51.61. So it took 13 years, but she got ahead. All right then. Well, by what amount does the total amount paid to K in her first 20 years exceed the amount paid to Anne in her first 20 years? So sum to N, arithmetic for Anne, and she ends up with $1,475,000. Sub into K's formula. Oh, smashed it. She's ended up with $13,903.93, more than Anne. Explain why the geometric series, so this sort of question, it's just wanting us to show that we understand the conditions for a limiting sum, and that condition is simply the ratios in between -1 and 1. So our one, the ratio is 1 on root 2 minus 1, which is about 2.4, so it does not have a limiting sum. No good. 2004, also on the limiting sum, but a lot more interesting. So it goes 1 minus tan squared plus tan to the power of 4. So when it does exist, so sometimes it will exist, sometimes it won't exist. But when it does exist, find its value. Okay, so A is 1, the ratio is minus tan squared. So A on 1 minus R, 1 plus tan squared becomes sec squared, reciprocal of sec squared. So the sum to infinity is cos squared. So does it exist? Well, limiting sums only exist in between 1 and 1. We want to know when is tan squared, or minus tan squared, in between -1 and 1. I've divided everything by -1. So if you change the sign, but here's the really cool thing. Oh, look, we're back to it again. Well, think about it. If minus tan squared's in between -1 and 1, tan squared's got to be in between -1 and 1, doesn't it? That means tan is also in between -1 and 1. We know that the tan of pi on 4 is 1. It's probably easier, I think, to use a graph to show this now, where it's equal to 1, so pi on 4 on the x-axis. We want to know when is that tan graph in between -1 and 1. Well, it must be when the x values are in between minus pi on 4 and pi on 4. So some applications there.